Function analysis, local extrema. Okay, again, just by looking at it, that's clearly a max, that's clearly a min, because that's the top of a mountain, that's the bottom of a valley. Visually, it's easy to see the relative extrema when we view the graph of a function. Right? It's just like, hey, there's the top of a mountain. There's another mountaintop. This mountaintop's bigger than that mountaintop, but I guess maybe I should be more specific. That makes that a local max. It's not the overall max, but locally it's at the top of a mountain. But if you didn't have the graph, it would be a lot harder to know where the maxes and mins are. So that's what we're going to worry about today, is how to find the max and min from an equation rather than from a graph. A relative max is a point where the function changes from increasing to decreasing. Well, yeah, that makes sense. Right? If you're climbing a hill and all of a sudden you change from going up the hill to down the hill, well, then you know that was the top of the hill. Sometimes calculus is easy. A relative minimum is where the function changes from decreasing to increasing. Well, yeah, same thing. Going down and you change to going up, that means wherever the change happened, that was the bottom of the hill, or the bottom of the valley. Let's look at the point a comma f of a. What is f prime at a? So what is the derivative of f at a? Emma, what's the slope of that tangent line? 0. All right. The sign of f prime changes from, so on this side, it changes, f prime. On the left side, Maddie, what's f prime on the left of, like right in here? Is f prime positive or negative? Positive. And Evan over here, what's f prime? It's negative because it's going down. So that means the sign of f prime changes from positive to negative at x equals a. All right, well, let's do the same thought process at point B. What is f prime at B? So, Helen, at B, what's the slope of the tangent line?
0.
Still 0. Or, like A, it's 0. Now let's talk about the signs of f prime. Ryan, you weren't here yesterday, but I bet you still know. What's the sign of f prime right here? Negative. Why is it negative?
Because it's going down.
Just be careful. Say f is going down,
F is going down.
as opposed to f prime is going down. Claire, how about on this side? What's f prime over here?
Positive.
How did you know that?
F is increasing.
Good catch. F is increasing. So, the sign of f prime changes from negative to positive at x equals b. We said previously that a corner or a cusp can be a relative extremum. In the above graph, the corner is a relative minimum, right? Just by looking at it, that's clearly a relative minimum. Does this negative to positive stuff still hold true at this minimum? Does f prime change from negative to positive across that point? Yeah. So it still holds true, even though that derivative at that point doesn't exist. On either side, it changes from, f changes from decreasing to increasing, so there's still a minimum there. So that's a yes. Okay, the box is super important. It has a lot of words, but all the words say exactly what we just said. If you change from slope positive to slope negative, you're at the top of a hill. If you change from slope negative to slope positive, you're at the bottom of a valley. So this is not a box to go home and memorize. This is a box to understand and think about. And so every time from here on out, I will almost always be doing my hand motions here. okay, that's a minimum, that's a maximum. I don't memorize the stuff. You read it, think about what f prime tells you, and you can answer the question. Let C be a critical number. Okay, so we already know what critical numbers are. That's, maybe we should remind ourselves, that's f prime equals 0 or doesn't exist. So that's our pool of potential maximums and minimums. So out of that pool, if the function is continuous, if f is differentiable, except possibly at c, there's a lot of words we don't have to worry about. Here's the big thing. If f prime changes from negative to positive at x equals c, so if f prime changes from negative to positive, then f has a relative minimum there. Yeah, again, that's not a memorized thing. That's the bottom of the valley. If f prime changes from positive to negative, so our slope went from positive to slope negative, we changed from increasing to decreasing, and that means there's a relative maximum there. If f prime is negative on both sides of c, or positive on both sides of c, then f of c is neither a max or min. What that would look like is, so maybe you hit a flat spot on the graph, like that. So that's a critical point, but f prime went from positive to positive, so yeah, that's not a max or a min. Same thing if it's decreasing and hits a flat spot. F prime changes, well, doesn't change, goes from negative to negative, so that's not a max or min. We're looking for where f prime changes signs, because then we've topped a mountain or bottomed out in a valley. We've talked about relative and local meaning the same thing. Relative max, local max, those are the same thing. Relative extremum, local extremum refers to either a max or a min. And then just some notes here. The plural of minimum is minima. The plural of maximum is maxima. The plural of extremum is extrema. I mean, I'm not going to take off if you say minimums. That's fine. Or extremums. But if you want to sound fancy, use the correct plural. Okay, so how in the world do we use this? Number one, find all relative extrema points. So, extrema, that just is a fancy way of saying max and min. I don't want both. For this graph, designate each as a max or min, and justify your answer. Well, justifying your answer is going to be the f prime changes positive to negative, or negative to positive. So, max and min, that sounds like I need f prime, because I want to know where f prime is changing signs. So, let's pick on 3 people. Why not? Get through more popsicle sticks that way. Caden, how about the derivative of x to the 4th? 4x to the 3rd. Hector, the derivative of minus 32x? Negative 32. And everyone's favorite, Isabel, the derivative of 4? 0. Okay, designate each as a... So I'm looking for where the sign of f prime changes. Thank you. So I need to do another one of those sign charts to figure out what's going on here. So let's set it equal to 0 first. I'll factor out the 4 just to make life a little easier. Maybe I should have talked big picture to begin with. To find maximum and minimums, I want to know where does f prime change signs. Like, that's what I'm looking for. That's what's motivating me for this problem. Because if I can find where f prime changes signs, then I'll have either a max or a min, depending on which way the sign is changing. let's see, x cubed minus 8 equals 0. X cubed equals 8. So x equals 2. That's my critical point. Only one of them. And I don't know if that's a min or a max or neither. So I'm going to do the f prime sign chart here. So I know f prime is 0 when x is 2. I want to know what happens to the left of 2 and to the right of 2. So you can pick any value you like, left of 2, and any value you like, right of 2. 0 seems like an easy pick. 3 seems like an easy pick. So I want to find f prime of 0. So that's easy. That's negative 32. So that means f prime is negative everywhere on that side of 2. F prime of 3. Oh, that looks a little bit harder. 4 times 3 cubed minus 32. Remember, I don't need the exact number. I just need to know if it's positive or negative. So 4 times 27 minus 32. I don't know. I don't really want to do all of that. But I'm pretty sure that 4 times 27 minus 32, is that positive or negative? Positive. 4 times 25 is 100. So more than 100 minus 32 is positive. So you get a little slack on your calculations here. As long as you know negative or positive, you'll be fine. So f prime changes from negative to positive at x equals 2. So what does that mean is happening at 2? I have to draw it out or see in my head. Some people even put like another row for f. If f prime is negative, then f is decreasing. If f prime is positive, then f is increasing. And so if you weren't already convinced it's a minimum, hopefully the arrow's like, oh, yep, that's a minimum. And so we need to say, this is the justify part, f prime changes from negative to positive at x equals 2. So x equals 2 is a local minimum. So the justify is the reason. You know it's a minimum because f prime changes negative to positive. You have to say that. When it says justify your answer, you have to have a statement that says f prime changes negative to positive, or the other way around if it was a maximum. Just a second, let me make sure I answered all of this question. Find all the extrema points. Okay, there was only one. Designated if it's a max or a min. We did that. It's a local minimum. Justify your answer. We knew it was a local minimum because f prime changed negative to positive. Emma.
So this is kind of a backtrack to your previous thing. Do you know the f prime equals 0, f prime equals does not exist? Do you know when we solve for does not exist?
That's a great question. The question was when do we, I did just kind of overlook the does not exist thing. And a lot of times we do that because this is always going to exist. 4x cubed minus 32.
Yeah.
So a polynomial, we're never going to have d and e. The main thing about the d and e is if there's a denominator.
Okay.
Because that would put a 0 in the bottom.
Okay.
I'm trying to think of other things. Like tangent would have some d and e's, but that really is a result of there being a denominator. The main thing is the denominator.
Okay.
So you're right to ask. I kind of glossed over it because most of the time we don't have to worry about it. Number 2. Find all values of x, if any, at which y equals x plus 2 sine x as a local max or local min on the interval 0 to 2 pi. Okay, so I'm not looking everywhere, just 0 to 2 pi. Classify each location as a max or min. Justify your answer. Okay, that's basically the same question as number 2, except I'm restricted to 0 to 2 pi. So if I'm talking local max, local min, I need to know where does f prime change signs. Because if f prime changes signs, then I've got either a max or a min, depending on which way the signs change. So I need a derivative first. Steps are going to be the same as number 1. Take a derivative, set it equal to 0, lay out the number line, test the intervals, and then you'll see where the increasing, decreasing stuff is. Okay, so I need 2 helpers for derivatives. Laura, what's the derivative of x?
1.
Yes. And Sophia, the derivative of 2 sine x? Good, 2 cosine x. Graham, what do I do with that now?
You solve for, or you set it equal to 0.
Good. Set it equal to 0, because I need to find the zeros in order to find the sign changes. So we set it equal to 0. So 2 cosine x equals negative 1. Cosine x equals negative 1/2. I don't have that memorized. I'm more thinking about the unit circle. Cosine is the left-right. So cosine is negative on the left-hand side. Cosine is the x-coordinate. So that would mean I'm at those 2 spots. So I'll walk you right up to the answer. Tristan, what's one of those angles? 2 pi over 3. And Marie, the other one? Good, 4 pi over 3. And be careful, yes, you could phrase that angle as negative 2 pi over 3, but why are we not including that as a possibility? It's not between 0 and 2 pi. So it's not, I mean, yes, it solves the equation, but it's not on the interval that we're allowed to look at. Okay, so 2 pi over 3, 4 pi over 3, those are my zeros, those are my critical points. Emma, I again just glossed over the undefined stuff. So it's a good question, but 1 plus 2 cosine is always defined, so I'm not worried about anything weird going on there. Number line, 2 pi over 3 and 4 pi over 3. So what would you like to check that's less than 2 pi over 3? Pi over 3 works. I was going to go 0, but pi over 3 might be better. How about something between 2 pi over 3 and 4 pi over 3? Pi. And then 5 pi over 3. Or 2 pi. But we would not want to go too far on this one because we know that the cosine is cyclical and we're only allowed to look between 0 and 2 pi. So we probably want our checkpoints in between 0 and 2 pi. So y prime at pi over 3. And again, I'm only worried about positive and negative, so if you miss it by a little bit, you might be okay, but you got to get the positive and negative right. Okay, 1 plus 2 cosine pi over 3. Cosine of pi over 3, it's definitely positive because it's in the first quadrant. So 1 plus 2 times a positive number is definitely positive. That's kind of lazy math, but all I care about is positive and negative. So as soon as I figure it's positive, we're good. Y prime at pi, 1 plus 2 cosine pi. What's the cosine of pi? Negative 1, because it's over there on the left. So 1 minus 2 is negative. we haven't done many of these, but you want to guess what happens on this third interval?
Positive.
Why do you think positive?
Because
I mean, have you done the problem already, I guess? Or do you see a pattern that has developed over these few problems that we've done?
points are assigned to, I guess the zeros are assigned to.
So there's usually a sign change there. Not always, so you have to be careful. Usually it alternates because there's a sign change, but not always, so be careful. It's okay to think that it's probably positive, but we want to make sure. Cosine phi of pi over 3, that's in the fourth quadrant, so that's positive. 2 times positive is positive. 1 plus positive is positive. So you get a little lazy on the math there, but all I care about is it's positive, so we're good. So looking at that picture, Harper, what would you say is going on at 2 pi over 3?
There's a change in signs.
Okay,
From positive to negative.
and what does that mean?
That it's a local maximum.
So local max. So x equals 2 pi over 3 is a local max. And then we have to say exactly what Harper said, because y prime changes positive to negative. So there's part of my answer. At 2 pi over 3, y prime changed from positive to negative. Positive to negative, so that's the top of the hill, that's the local max. Elizabeth, what would you say about 4 pi over 3?
That it's a local minimum because it changes from negative to positive.
I would take one small quibble with what you said. You said x equals 4 pi over 3 is a local minimum because it changes negative to positive. There you go. Y prime changes negative to positive. No, it's allowed because we don't know if you're talking about y or y prime or later on y double prime. Are you referring to g or f? Because there might be two different equations. So don't ever say it in an explanation. I'll probably know what you're talking about, but you need to be clear. Oh, I didn't draw the picture for y, but if it helps. So if y prime is positive, y is increasing. If y prime is negative, y is decreasing. If y prime is positive, y is increasing. And so, if you're a visual person, that might even help you see further that, yeah, there's a maximum there and a minimum there. Okay. Every year I haven't told you about my favorite Facebook group. It's a group of calculus teachers who ask questions of each other and get good answers. Primarily because there's College Board people on there who know the answers. Every year someone will ask, is the sign chart good enough? Like, clearly there's my sign chart, so I can tell by looking at my sign chart that x equals 2 pi over 3 is a local max. And the answer is always no. The sign chart helps you know what the answer is, but you have to state y prime changes positive to negative or negative to positive. So this is great information. It helps you figure out the answer, but the justify has to be the y prime is changing signs. Emma.
Couldn't you just, because we already have the equation, if you know how to write the sign equation, couldn't you just draw it if you have the x values and then figure out, then just visually look to see where it is?
So the question is, if you knew how to graph that, could you use the graph? I don't think so, because in calculus we want you to give a calculus answer. The other answer is, do you really know how to graph that?
Yeah. No.
I mean, it's probably not. And that one was pretty simple. That's about as simple as they get, and I don't know how to graph that. I mean, I kind of know. It's y equals x is this, and sine of x is... So it's probably a sign that's kind of going... But, So, no, you need to say what's going on. That's a good question. Last one. Which of the following is true if f of x equals d dx over cosine of x on the interval 0 to 2 pi? And the questions are all about mins and maxes, so I need to know about f prime changing signs. Emma, not to put you on the spot, but do you know what we're going to have to worry about on this one? What's that? Yeah, that does not exist. Why are we going to be worried about that, or what's going to make us? Anybody? There's a denominator, so I'm pretty sure I'm going to have to worry about some does not exist on this one. Okay, so again, I don't want to do quotient rule on the fly. I want to find the pieces and then put it together. So Lexi, help me out. If f is the top, that's e to the x. What's the derivative of e to the x? E to the x, yep. It's our favorite derivative. Braden, what's the derivative of cosine?
Negative sign.
Good, negative sign. All right, now we're ready to put this thing together. So the overall derivative, we already did one quotient rule today. Gf prime minus fg prime. Gf prime, so e to the x cosine x, gf prime, minus the other way around, although there's a negative sign in there, so negative e to the x sine x, all over cosine of x squared. Okay, I'm looking for where f prime is 0 because I'm thinking about sign charts, thinking about changing signs. Let's factor out the e to the x, cosine x plus sine x, all over cosine of x squared. Okay, so f prime equals 0 when the top is 0. And f prime doesn't exist when the bottom is 0. Took a derivative, set them equal to 0. So I'll find this set of answers, whatever that is. I'll put those on a number line, and then I'll have to check the plus and minus stuff. When is e to the x going to be 0? Never. So cosine of x equals negative sine of x. We've hit this a couple times already. It's like they want to make sure you know what that answer is. So where does cosine equal negative sine? Yeah, at the over 4s in the opposite quadrants there. So 3 pi over 4 and 7 pi over 4. And then a critical point is when, well, we could square root both sides, when cosine of x equals 0. Where does that happen? Pi over 2, 3 pi over 2. That's kind of annoying because I got a number line with all these things on it. We better put them on in order or else we'll really get confused. 3 pi over 4. Nope, I almost put that on out of order. Pi over 2 would be smaller than 3 pi over 4. Maybe looking at it on one picture would help. Pi over 2, 3 pi over 4, 3 pi over 2, and then 7 pi over 4. Oh man, I gotta check 1, 2, 3, 4, 5 intervals of f prime. So let's check the 0. And then an answer between pi over 2 and 3 pi over 4. The picture might help. Between pi over 2 and 3 pi over 4. You can go 2 pi over 3. Between 3 pi over 4 and pi over 2, I'll probably go with pi. And then another weird one down here. What is that? Over 3 in the fourth quadrant. 5 pi over 3. And then may as well go all the way to 2 pi for that next one. Oh, this is going to be a pain. But we look at our f prime. What's this? We're only concerned about signs. What's the sign of e to the x? Always positive. And what happens when we square something? What do we get? Positive. So it's ugly, but it really, the only thing I'm concerned with is cosine of x plus sine of x, whether that's positive or negative. Okay, let's see. So if I plug in 0, cosine of 0 is 1, sine of 0 is 0, so that's positive. Plug in 2 pi over 3. Oh, that's in the second quadrant. So the cosine is negative, the sine is positive, but which one's bigger? Sine, because it's the steep angle there, so that's positive. So there was not a sign change there. Plug in pi. Back to drawing the unit circle here. Cosine of pi is negative 1. Sine of pi is 0. So that's negative. 5 pi over 3. Let's see. That would be cosine is negative. No, cosine's positive. Sine is negative. But the sine's a bigger value, so that one's negative. And then at 2 pi, cosine is 1, sine is 0, so that's positive. Okay. So, how many sign changes do we have? 2. What's happening at 3 pi over 4? Is that a max or a min? It's a max, because we went from increasing to decreasing. And then at 7 pi over 4, we went from decreasing to increasing, so that's a min. The other things weren't even sign changes, so it looks like there's one max and one min. What a long problem. Alright, today's assignment, worksheet 2, the rest. Worksheet 2, 9 through 16. And all we're worried about, I mean, I say this like it's easy, but from a calculus standpoint, all we're worried about is where does f prime change signs. The hard part is all the algebra that goes with it.